Hello everyone. In previous class, we discussed about inverting and non-inverting operational amplifier. पिछले वाली क्लास में हमने देखा इन्वर्टिंग और नॉन इन्वर्टिंग एम्पलीफायर सर्किट जो होते हैं उनका वर्किंग, उनका सर्किट डायग्राम हमने स्टडी किया था. Now, in this lecture, we will study about what is the summing amplifier, or we can say that the summer amplifier. In this topic, we will study about what is the summing amplifier, its circuit diagram, its application, and some examples. So the next topic is the differential amplifier. In this topic, we will study about the circuit diagram, application of differential amplifier, as well as some example related to differential amplifier circuit. After this, we will move on the next topic is a इंस्ट्रूमेंटेशन एम्पलीफायर. इसमें भी हम देखेंगे इसका सर्किट डायग्राम, वर्किंग क्या कैसे करता है और इसके एप्लीकेशन क्या क्या है. And finally, the references of this presentation. So in this lecture, we cover all these topics one by one. So let's start with topic 1, the summing amplifier. So what is the summing amplifier? The summing amplifier is another type of operational amplifier. Actually ये एक operational amplifier का ही type है. Configurations that it is used to combine the voltage present on two or more inputs into a single output voltage. Actually हम करते क्या है, इनपुट में हम दो या दो से ज़्यादा इनपुट जो होते हैं उनको सम करने के लिए इसका यूज़ करते हैं, या कंबाइन करने के लिए, कंबाइन करके सम करने के लिए हम समिंग एम्पलीफायर का यूज़ करते हैं और आउटपुट में हमें एक सिंगल सिग्नल मिलता है. तो समिंग एम्पलीफायर क्या करता है, इनपुट सिग्नल को सम करके आउटपुट हमें सिंगल सिग्नल के फॉर्म में देता है. We saw previously in the inverting operational amplifier that the inverting amplifier has a single input voltage Vn applied to the inverting input terminal. If we add more input resistor to the input, each equal in value to the original input resistor Rn, we end up the another operational amplifier circuit called a summing amplifier or summing inverter, or even a voltage adder circuit as shown in a figure. इसको हम voltage adder circuit भी बोलते हैं क्योंकि अगर इनपुट में हम वोल्टेज दे रहे हैं दो या दो से ज़्यादा, तो ये वोल्टेज को ऐड करके हमें आउटपुट में सिंगल आउटपुट सिग्नल प्रोवाइड करता है. नाम से ही समझ में आ रहा है, समिंग मीन्स ये इनपुट सिग्नल को सम करके आउटपुट हमें देगा. So this is the diagram for summing amplifier. देखिए आप देख पा रहे हैं इनपुट में यहाँ पे जो है मेरे पास ये कई सारे इनपुट्स हैं, इसको सम करके ये जो एम्पलीफायर है इसको हम बोलते हैं समिंग एम्पलीफायर. ये इनका सम करके हमें आउटपुट में एक सिंगल आउटपुट सिग्नल जो है प्रोवाइड करता है. In the simple summing amplifier circuit, the output voltage Vout now become proportional to the sum of the input voltage V1, V2 and V3. ये हमारे पास इनपुट वोल्टेज है V1, V2, V3. इसको हम वोल्टेज एडर इसलिए बोलते हैं क्योंकि इनपुट में हमने अभी इसमें वोल्टेज दिया हुआ है, तो इन सारे वोल्टेज को ये ऐड करके हमें आउटपुट देगा. Then we can modify the original equations for the inverting amplifier to take account of these new inputs. Thus, IF is equal to I1 plus I2 plus I3, और we can know that V is equal to IR, so I is equal to V upon R. So उससे हमने I1 की वैल्यू हमारे हो जाएगी V1 by Rn plus V2 by Rn I2 की, और I3 की V3 by Rn. So this is the equation. Now inverting equation Vout is equal to minus of Rf divided by Rin into Vin. Then minus of Vout is equal to Rf divided by Rn into V1 plus Rf divided by Rn into V2 plus Rf divided by Rn into V3. However, if all the input impedance Rin are equal in value, we can simplify the above equation to an output voltage of summing amplifier equation. So the summing amplifier equation is Rf by Rin को हम equation से common निकाल लेंगे. So the output voltage Vout is equal to Rf divided by Rin in bracket V1 plus V2 plus V3 and so on. अगर हम और भी ज़्यादा इनपुट लेंगे वोल्टेज के तो इसमें हम जितना भी वोल्टेज लेंगे उनको हम ऐड करते चले जाएंगे. We now have an operational amplifier circuit that will amplify each individual input voltage and produce an output voltage signal that is proportional to the algebraic sum of the three individual input voltage like V1, V2 and V3. We can also add more input if required, as each individual input sees their respective resistance Rin as the only input impedance. This is because the input signals are effectively isolated from each other by the virtual earth node at the inverting input of the operational amplifier. A direct voltage addition can also be obtained when all the resistance are equal value and Rf is equal to Rin. Note that when the summing point is connected to the inverting input of the operational amplifier, the circuit will produce the negative sum of any numbers of input voltages. Likewise, when the summing point is connected to a non-inverting input of the operational amplifier, it will produce the positive sum of the input voltage. तो अब हमारे पास दो ऑप्शन है. अगर हमें नेगेटिव सम चाहिए है तो हमें जो है समिंग जो पॉइंट है, समिंग पॉइंट को हमें कहाँ ऐड करना पड़ेगा? इन्वर्टिंग इनपुट्स में. और अगर हमें चाहिए पॉजिटिव सम तो हमें समिंग पॉइंट को ऐड करना पड़ेगा नॉन इन्वर्टिंग इनपुट्स में. A scaling summing amplifier can be made if the individual input resistance are not equal. Then the equation would have to be modified too. So Vout is equal to V1 in bracket Rf divided by R1 plus V2 in bracket Rf by R2 plus V3 in bracket Rf by R3 and so on. To make the math a little easier, we can rearrange the above formula to make the feedback resistor Rf the subject of the equation, giving the output voltage as Vout is equal to Rf. हमने equation से common निकाल लिया equation को easy करने के लिए. So Rf whole common in bracket V1 by R1 plus V2 by R2 plus V3 by R3 and so on. This allows the output voltage to be easily calculated if more input resistors are connected to the amplifier inverting input terminals. The input impedance of each individual channel is the value of their respective input resistance, that is R1, R2, R3 and so on. Sometimes we need a summing circuit to just add together two or more voltage signals without any amplification. By putting all the resistances of the circuit above to the same value R, the operational amplifier will have the voltage gain of unity and the output voltage equal to the direct sum of all the input voltage. So this is the diagram for summing amplifier. The summing amplifier is a very flexible circuit indeed, enabling us to effectively add or sum, hence its name, together several individual input signals. If the input registers R1, R2, R3, etc. are equal, a unity gain inverting adder will be made. However, if the input registers are of different value, a scaling summing amplifier is produced, which will output a weighted sum of the input signal. तो अगर हमारे पास जो हम इनपुट रेजिस्टेंस ले रहे हैं उनकी वैल्यू अगर इक्वल है तो हम बना सकते हैं यूनिटी गेन इन्वर्टिंग एडर, या हम बोलें कि उससे जो हमारा एडर बन के आता है वो यूनिटी गेन इन्वर्टिंग एडर होता है। और अगर हमारा रेजिस्टेंस की वैल्यू जो इनपुट रेजिस्टेंस है वो डिफरेंट हुई तो उससे जो बन के निकलेगा उसको हम स्केलिंग समिंग एम्पलीफायर सर्किट बोलेंगे। Next is example of summing amplifier. Question is that find the output voltage of the following summing amplifier circuit. इस summing amplifier circuit का हमें output voltage निकालना है। चलिए कैलकुलेट करते हैं। So using the previously found formula for the gain of the circuit is gain AV is equal to, or we can say that voltage gain is equal to V out divided by Vin is equal to minus of RF divided by Rin. RF हमारा जो होता है वो फीडबैक रजिस्टर होता है और Rin जो होता है वो इनपुट रेजिस्टेंस होता है। So now we can substitute the value of the resistors in the circuit as follow. So the value of A1 is equal to 10 kilo ohm divided by 1 kilo ohm. So we get minus of 10. And the value of A2 is equal to 10 kilo ohm divided by 2 kilo ohm, so we get the value of minus 5. So this is the simple example for summing amplifier circuit. तो इस तरीके से हम कैलकुलेट कर सकते हैं। We know that the output voltage is the sum of the two amplified input signal and is calculated as V out is equal to A1 into V1 plus A2 into V2. So finally the V out is equal to, put the value minus 10 in bracket 2m into V plus minus 5m into V. So we get minus 45 millivolt. Then the output voltage of the summing amplifier circuit above is given as minus 45 millivolt and is negative as it's an inverting amplifier circuit. Now next is a non-inverting summing amplifier. But as well as construction inverting summing amplifier, we can also use the non-inverting inputs of the operational amplifier to produce a non-inverting summing amplifier. We have seen above that an inverting summing amplifier produces the negative sum of its voltages. Then it follows that the non-inverting summing amplifier configurations will produce the positive summing of its input voltage. So this is the diagram for non-inverting summing amplifier. देखिए नॉन इन्वर्टिंग समिंग एम्पलीफायर हम इसको क्यों बोल रहे हैं, क्योंकि इसमें हम जो समिंग वाला पोर्शन लगा रहे हैं वो नॉन इन्वर्टिंग और प्लस टर्मिनल में ऐड कर रहे हैं. सो दिस इज कॉल्ड द नॉन इन्वर्टिंग समिंग एम्पलीफायर सर्किट. As its name implies, the non-inverting summing amplifier is based around the configuration of a non-inverting operational amplifier circuit in that the input, either AC or DC, is applied to the non-inverting plus terminal, while the required negative feedback and the gain is achieved by feedback some portion of the output signal V out to the inverting minus terminal as shown in a figure. तो डायग्राम में हमने देखा है कि जो समिंग वाला पॉइंट है वो हमने नॉन इन्वर्टिंग टर्मिनल में ऐड किया है और फीडबैक को हमने इन्वर्टिंग टर्मिनल में दिया हुआ है. इस तरीके से हम नॉन इन्वर्टिंग समिंग एम्पलीफायर सर्किट डिजाइन कर सकते हैं. So what can we use summing amplifier for either inverting or non-inverting if the input resistances of a summing amplifier are connected to potentiometer? The individual input signal can be mixed together by varying amounts. For example, measuring temperature, you could add a negative offset voltage to make the output voltage or display read 0 at the freezing point, or produce an audio mixer for adding the mixing together individual waveform or sounds for the different source channel like vocal, instrumentation, etc. before sending them combined to an audio amplifier. Next is a summing amplifier audio mixer. So this is the diagram for audio mixer, summing amplifier audio mixer. Another useful application of summing amplifier is as a weightage sum digital to analog converter, means DAC. If the input resistor Rn of a summing amplifier double in the value of each input, for example 1 kilo ohm, 2 kilo ohm, 4 kilo ohm, 8 kilo ohm or 16 etc., then a digital logic voltage, either a logic label 0 or the logic label 1, on these inputs will produce an output which is the weightage sum of digital input. Consider the circuit shown in a figure. All about related to summing amplifier. The next one is a differential amplifier. The differential amplifier amplifies the voltage difference present on its inverting and non-inverting inputs. बहुत ही सिंपल सा नाम से समझ में आ रहा है कि ये जो दो हमारे पास इनपुट होते हैं, इन्वर्टिंग और नॉन इन्वर्टिंग, इन दोनों के बीच का दो सिग्नल अगर हम इनमें देंगे तो उनके बीच में जो डिफरेंस होगा उसको ये क्या करता है, एम्पलीफाई करता है. सो दिस इज कॉल्ड द डिफरेंशियल एम्पलीफायर. Thus, for we have used only one of the operational amplifier input to connect to the amplifier using either the inverting or the non-inverting input terminal to amplify a single input signals with the other input being connected to the ground. But as a standard operational amplifier has two inputs, inverting and non-inverting, so we can also connect signals to both of these inputs at the same time, producing another common type of operational amplifier circuit called as a differential amplifier. Basically, as we saw in the first tutorial about the operational amplifier, all the operational amplifier are differential amplifier due to their input configuration. But by connecting one voltage signal onto one input terminal and another voltage signal onto the other input terminal, the resultant output voltage will be proportional to the difference between the two input voltage signal of V1 and V2. The differential amplifier amplifies the difference between the two voltage mix, or making this type of operational amplifier circuit a subtractor unlike a summing amplifier, which add or sum together the input voltages. This type of the operational amplifier circuit is commonly known as a differential amplifier computations and is shown in a figure. So this is the circuit diagram for the differential amplifier circuit. इसमें क्या होगा, इसमें इन्वर्टिंग और नॉन इन्वर्टिंग हमारे पास जो इनपुट्स हैं, इन दोनों के बीच का डिफरेंस जो है उसको ये एम्पलीफायर है वो एम्पलीफाई करके देता है. सो दिस इज नोन एज द डिफरेंशियल एम्पलीफायर. By connecting each input in terms of 0 volt ground, we can use superposition to solve for the output voltage Vout. Then the transfer function for the different amplifier circuit is given as, so the value of I1 is equal to V1 minus VA divided by R1. Similarly, I2 and I3. So the summing point VA is equal to VB. And VB is equal to V2 in bracket R4 divided by R2 plus R4. If V2 is equal to 0, then the Vout A is equal to minus of V1 R3 divided by R1. If V1 is equal to 0, then V out B is equal to V2 in bracket R4 divided by R2 plus R4 bracket close into R1 plus R3 divided by R1. So the V out is equal to minus of V out A plus V out B. So the final value of V out is equal to minus of V1 into R3 divided by R1 plus V2 R4 divided by R2 plus R4 into R1 plus R3 divided by R1. When resistor R1 is equal to R2 and R3 is equal to R4, the above transfer function for the differential amplifier can be simplified to the following expression. So this is the differential output equation. V out is equal to R3 divided by R1 in bracket V2 minus of V1. If all the resistors are all of the same ohmic value, that is R1 is equal to R2 is equal to R3 is equal to R4, then the circuit will become a unity gain differential amplifier. And the voltage gain of the amplifier will exactly 1 or unity. Then the output expression would simply be V out is equal to V2 minus of V1. Also note that if the input V1 is higher than the input V2, then the output voltage sum will be negative, and if the V2 is higher than V1, then the output voltage sum will be positive. The differential amplifier circuit is a very useful operational amplifier circuit, and by adding more resistor in the parallel with the input resistor R1 and R3, the resultant circuits can be made to either add or subtract the voltage applied to their respective inputs. One of the most common way of doing this is to connect a resistor bridge, commonly called a Wheatstone bridge, to the input of the amplifier as shown in a figure. So this is the circuit diagram for the Wheatstone bridge differential amplifier. The standard differential amplifier circuit now become a differential voltage comparator by comparing one input voltage to the another. For example, by connecting one input to a fixed voltage reference set up on one leg of the resistor bridge network and the other to either thermistor or a light dependent resistor, the amplifier circuit can be used to detect either low or high level of the temperature or light, as the output voltage become a linear function of the changes in the active lag of the resistor bridge, and this is demonstrated below. So the second example is a light activated differential amplifier. So differential amplifier also used for the light activated purpose. This is the circuit diagram for light activated differential amplifier circuit. So this is all about the differential amplifier. The next topic is the instrumentation amplifier. So what is instrumentation amplifier? Instrumentation amplifier in amps are very high gain differential amplifier which has a high input impedance and a single-ended output. Instrumentation amplifier are mainly used to amplify very small differential signal from steam gauge, thermocouples or current sensing devices in motor control system. Unlike standard operational amplifier in which their closed loop gain is determined by an external resistive feedback connected between their output terminal and one input terminal, either the positive or negative. Instrumentation amplifier have an internal feedback resistor that is effectively isolated from its input terminals as the input signal is applied across the two differential inputs V1 and V2. The instrumentation amplifier also has a very good common mode rejection ratio, means CMRR, or we can say that zero output when V1 is equal to V2. Well, in excesses of 100 dB at DC. A typical example of three operational amplifier instrumentation amplifier with a high input impedance means Zn as shown below. So this is the high input impedance instrumentation amplifier. The circuit diagram for high input impedance instrumentation amplifier. So in a figure, the two non-inverting amplifier from a differential input stage acting as a buffer amplifier with a gain of 1 plus 2 into R2 divided by R1 for a differential input signals and unity gain for common mode input signals. Since amplifiers A1 and A2 are closed loop negative feedback amplifier, we can expect the voltage at VA to be equal to the input voltage V1. Likewise, the voltage at VB to be equal to the value of at V2. As the operational amplifier takes no current at their input terminal, means it is virtually ground or earth, the same current must flow through the three resistor network R2, R1 and R2 connected across the operational amplifier outputs. This means then that the voltage on the upper end of the R1 will be equal to the V1 and the voltage at the lower end of the R1 to be equal to V2. This produces a voltage drop across the resistor R1 which is equal to the voltage difference between the input V1 and V2, the differential input voltage, because the voltage at the summing junction of each amplifier VA and VB is equal to the voltage applied to its positive inputs. However, if a common mode voltage is applied to the amplifier inputs, the voltages on each side of R1 will be equal and no current will flow through this resistor. Since no current flow through R1 nor therefore through both R2 resistor amplifier A1 and A2 will operate as a unity gain follower or buffer. Since the input voltage at the output of the amplifier E1 and A2 appears differentially across the three resistor network, the differential gain of the circuit can be varied by just changing the value of R1. The voltage output from the differential operational amplifier A3 acting as a subtractor is simply the difference between its two inputs V2 minus V1 and which is amplified by the gain of A3 which may be 1 or unity. Assuming that R3 is equal to R4, then we have general expression for overall voltage gain of the instrumentation amplifier circuit is V out is equal to V2 minus of V1 in bracket 1 plus 2R2 divided by R1 into R4 divided by R3. In the next tutorial about the operational amplifier, we will examine the effect of the output voltage V out when the feedback resistor is replaced with a frequency dependent reactance in the form of capacitance. The addition of this feedback capacitor produces a non-linear operational amplifier circuit called as an इंटीग्रेटिंग सर्किट और इंटीग्रेटिंग एम्पलीफायर। तो इंटीग्रेटिंग एम्पलीफायर को हम नेक्स्ट लेक्चर में पढ़ेंगे। ये लेक्चर हमारा काफ़ी लंबा हो चुका है, इसलिए हम नेक्स्ट लेक्चर में स्टडी करेंगे इंटीग्रेटेड एम्पलीफायर और some other types of amplifier. So next is an integrator amplifier. ये हम नेक्स्ट वाले लेक्चर में पढ़ेंगे। Now finally the references of this presentation. So these are the references. And thank you for watching this video.